Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to our NPTEL online certification courses on engineering drawing and computer graphics. We are at module number 5, lecture 45. In this module, we will mainly focus on sections and sectional views. When do we require these sections and sectional views? What are the importance of these sections? These are the things what we are going to learn in our module number 5. Let us begin our sectional views topic. Mainly to represent prisms, cylinders, pyramids, cones or perhaps assembly drawings where different parts have been assembled, joined together. To understand these intricate details, we require sections. The main reason for creating a section view is elimination of the hidden lines, so that a drawing can be more easily understood or visualized. For example, if I am drawing a cylinder, in drawing if I would like to represent, perhaps the views will be the front view and top view of that, we represent it in that way. How to know whether it is a solid object or a hollow one? To represent that, we require this kind of sectional views. For example, if it is just a sheet metal, a very small thickness, when we are representing it at the front view, we do not know whether it is a solid object or it is a hollow one, unless we make a cut section, remove this first part and show something like where sheet metal can be represented by a thick line. That indicates that material might be present within that red portion and the white portion there is no material. Further purpose, we require these sections. More details we will learn during the class. Usually these sections representation helps us to improve clarity and reveal interior features of the parts. And these interior features of very complicated assemblies are always be preferred on these sectional planes. For example, we have a monitor. At front view, we will see something like a rectangular portion, but inside what it is there, we do not know. So, for that purpose, usually on drawing sheets, whoever so manufacturing these computer monitors or perhaps trying to know about the individual components of that monitors, the best part is they will represent something like a sectional view, making a slice which pass through this computer monitor. So, the top part will be removed and bottom part can be visualized, so that we will understand what kind of electronic components are present. And that kind of drawings usually we circulate across this production line. So, this is the way one has to make assembly. For that point of view, the sectional views are very helpful. Or perhaps we have a writing pen. So, from front view, top view, we just see something like a cylindrical portions with conical portion and so on. But whether inside a thin refill is present, thick refill is present, how to know about that on the drawing sheet? When you are communicating with other assembly plants, usually you circulate these drawing sheets on which is clearly represented, like if you are having this sectional representation, perhaps such kind of refill one might be using it. For that point of view also we require these views. So, traditional section views are based on the use of an imaginary cut plane that pass through the object to reveal interior features. It is not that we slice it, but it is more like an imaginary process. If one can really have that kind of sectional thing, inside parts, how do they look like? This imaginary cut plane is controlled by the designer and can go completely through the object. If that is happening, we call full sectional view. For example, we have a water bottle and if we are going to have something like this plane, slice it. So, let us call back side part B, front side part F, remove this front side part, and if you are looking back side part, it looks like perhaps if it is made with a plastic, a very thin material, this is the part where we have this plastic material and the remaining place is empty. So, to represent this kind of things, we use certain kind of protocols, whether we should really darken those lines or show some kind of inclined lines, hashing and so on. This kind of representation what we will learn for this sections and sectional views chapter. Instead of removing complete full section, one can make half section also. It is more like go halfway through the object. Sometimes sections can go neither normal nor on these horizontal things, but some bent kind of views also one can make it. Very complicated objects if they are present, unless we show that bent kind of sectional views, we will not be in a position to understand what is there inside of that material. And sometimes it completely goes through the part, but something named broken cut sectional views. More details we will see later. A cut plane line is the one which show where the cut plane passed through the object. It represents the edge view of the cutting plane and are drawn in the view adjacent to the sectional view. So, two concepts are important, one is cut plane, other one is cut plane line. For example, we have a block, perhaps maybe cut plane is that which pass through these points. When we are looking from top view, it looks like there is a plane which pass through this material with certain arrow representation we will give, and this one what we call line, cut plane line, and this one is called cut plane. Let us take an example. Here we have an object, these are the holes through which it can be bolted, and this is a hollow portion inside, and we have a slight taper on that side. If we make a cut section, perhaps here cut section what we are trying to do is up to that part remove it, similarly up to that part remove it. So, if we can remove this part, the leftover part perhaps looks like that. By doing this, the advantage is we can clearly see up to which length this bolt can really go. Here it goes all the way down. Second thing, we have a step, that step can be clearly seen. And the third one, here inside whether the taper is there or not, that we can clearly see that. And the thickness of that material can be clearly seen. And further, whether the same thickness we will see it on both sides or not. This kind of intricate details we can easily observe through these sectional views. So, on drawing sheet, instead of representing these complex 3-dimensional shapes, usually we go with the 2D sketches, especially the projections, orthographic projections. And if it is about this object, having a front view in this direction, we will represent this end matches with this, and we have something like a bolt insertion kind of position that we can represent it here. Similarly, this one we can represent it there, and it is hollow inside that. For that we have these dashed lines. There is a tapered one, that is the reason we have that tapered one, and it is hollow. So, again we have that hollow. All the way we have this hollow portion which goes all the way down. This is the way we represent front view of this pedestal kind of bracket. In case if we have a cut section, we can clearly see the material, and a 2D level representation, we can show only that part where there is hollow portion, one can note it up to which level, and this is the plane through which this cut section is really passing through, and material is present there. So, usually we show 45 degrees inclined lines where material is present, and that is what we call hashing, hash. One can have complete section show that, but it is because it is symmetric object, the same thing one will be in a position to sense it on the other side. So, it is a minimalistic way of representing figures. One can have a full section show the same object. Instead of that, the standard convention is, if these are symmetric kind of objects, 1/4 of the portion one can really remove it, the remaining portion one can show it by hashed lines, and this is one view of that object, the frontal view. For example, if we have this kind of block, if there is a cut plane we have chosen, observe that arrows are pointing in that direction, and there is a dash, small dash lines. So, a very long dash followed by 2 small dash lines goes all the way. These are not just stopping on the object, but extend all the way on top side and bottom side, and there is some arrow representation. And if we do that, usual representation is in the direction of arrows, we keep the object, away from that remove the remaining portion. So, arrow direction is in this way. That means, this part we will keep it and this part we will remove it. When we remove it, after making a slice in that direction, similarly when you have a section through cut plane, if you are removing it, there is no material here, it is just blank empty vacuum. That is the reason we have empty thing. But this is the portion where we have material, that material what we are representing by this. Similarly, material is present there. This is the way we get resulting section. Usually, the cut planes represented by a thick dash line that extend past the edge of the object. This is the edge of that object, but it passes over that 6 mm. So, minimum 6 mm length one has to show when you are showing a section. For example, if the object is this, you want to cut, you do not just show it in that way. What you do is represented by these dash lines. One way is long dash, dash dash, long dash, dash dash, long dash. Such kind of extension we will have. We want to keep this one, then arrow direction supposed to be in that direction, and this is the one which we would like to remove. And these segments at each end drawn at 90 degrees and terminated with arrows. So, this always be having 90 degrees. Let us look at another example. Here we have a block which is having a hole inside of that. Perhaps there is no hole on this side, and we will like to consider a sectional view of this entire block. The sectional cut plane is an imaginary plane. This is the one. This passes through these lines, and arrow direction is in that way. That means, we want to preserve that view and remove this part. So, this part comes out and the remaining part we represent. Because it is a sectional view, we always have this material portion represented by hash lines. Similarly, here hash, and similarly this one. And note the arrow direction. So, if we are looking at front view of the object and top view of the object, we can clearly see that. We would like to view front view in this direction. Perhaps we would like to visualize from bottom side one way, or we would like to view from this direction as a front view, and the remaining top view whatever we would like to really visualize, that we might be showing it in that way. Now, if we are using first angle projection, your front view at top and top view at bottom. If one is going with third angle projection, your front view and top view. So, based on those view directions, we can see that the front view portion have that material element. However, because of view, this point maps there and we will be in a position to see this line and also this one. So, we will be in a position to see this complete portion, and there is a tiny hole passing through that we can represent by this long dash line. This is the way we get a sectional view of the object. Usually the section will be represented in other view, maybe here in the top view, where section has to be considered on that object which is passing at the middle layers of that block, and we want to remove this portion, keep the view of that, then naturally arrows we will represent it in that way. We should not show arrows in this direction for this object. It indicates that we want to retain this, but we want to remove it, whereas the case is the other way around. So, arrows should be in the line of sight. There are basically two types of lines are acceptable for this cut plane lines. Either by showing a long dash lines with each dash of 6 mm and the gap between these long dashes will be 1.5 mm, and the arrows always be representing 90 degrees line. The other way is showing long dash followed by 2 dash lines and again long dash. So, a long dash, small 2 dashes followed by long dash. The gap between these long dash and short dash is 1.5 mm. Usually this long dash will have around 20 mm to 40 mm in length, and short dash usually have a length of 3 mm. And for this cut plane we always use capital letters, and these are placed at each end of the cut plane. So, here if you are seeing cut plane C and B and B. For example, for a cylinder we want to make a cut plane, this is the cut plane direction. So, long dash followed by 2 small dashes, long dash followed by 2 dashes and so on. We want to retain that side view, then this is the plane, and usually this one ends with B, B, A and so on, capital letters we use it. And if these are cylindrical kind of objects, center lines are there, then cut plane line always have a precedence compared to axis or center line. Let us look at that object. For example, here we have a front view, a top view, if it is in third angle projection, and a side view we have it. So, here we have something like a long dash, short dash, long dash, just to represent the center of that circle or perhaps circular location. And here we are showing long dash followed by 2 short dashes, long dash and so on as a sectional view. When we have such kind of thing, we will represent only that sectional view representation, but we do not show anything like long dash, short dash, long dash to represent center. So, compared to the center line, if there is a sectional view line is present, cut plane line, then one has to show only that cut plane line. So, if we are removing this part, the section what we are going to get is these views, because we are removing this part, because arrow direction is in this direction. So, we want to retain that part, remove this part. When we do that, on the side view we can clearly see that this is the place where material is present, represented by that. And because this is a hollow portion, this is also a hollow portion. So, we do not have any lines there, it just looks like floating one. Similarly, we have an extra material and tapered kind of thing, then naturally we will have this portion. If you have frustums, cylinders, tapered kind of things, we always have this sectional view representation only on that 1/4 of that quarter. So, instead of showing complete half full section kind of thing, we use remove this part. When we remove that part, if we are looking from this side view, there is a material present in this zone, and that is the one what we are seeing there.